Okay, welcome everyone. And I'd like to share with you an experience we had this summer in the Grand Forks District with three-dimensional ground penetrating radar, or in short, 3D GPR. In general, I think 3D GPR differs from GPR, regular ground penetrating radar, in a sense that it's actually three-dimensional, and you actually get coverage across the whole width of the road as well as longitudinally. And so you probably see the van here in the picture on the left here. And so this van is owned by the Minnesota Department of Transportation, and they nicknamed it the Road Doctor because it has so many different technologies that they're using to evaluate their roadways over there. It has about 8 or 9 technologies, LiDAR, as you can see on top, and then the ground penetrating radar equipment, as you see here. So representatives from the MnDOT graciously came down and to Grand Forks and collected data on one of our interregional sections here on Highway 2, just west of Grand Forks. And so I'd like to tell you a little bit about that. So I think the idea of coming up here and collecting data actually came about from a number of us, including Amy and Aaron and Adam and myself, attended the 2024 NRRA pavement conference last spring. And at the end of the conference, we actually got to go to the Road test track and spend the rest of the afternoon there. So they had a number of stations set up along the test track. And one of them was this Road Doctor, and so we got talking about it, and you may be able to see maybe in the upper right there's a person by the name of Eob Zaghi, and he actually explained to us and gave a really good presentation on the Road Doctor. So we got talking about, maybe there's a chance that we could come up and get some data on one of the North Dakota roadways. So a few weeks went by, and thanks to Aaron to keep this thing going, we got a road decided on a road for them to come up and collect. So it happened to be on US 2 eastbound from 329 to about 341.7, which is about a mile west of starts at about a mile west of Larimore Turnoff and goes to the base, as you can see from the map here. So this particular section was part of the reason it was picked is because it had a unique section to it. As you can see in the upper left, it was constructed in 78, 79, and there was what they call a lean concrete base, or an econocrete base constructed. And this material was, to near that I can tell from the special provision, was plant mixed and then brought out to the field and placed at 6 inches, and then it was actually rolled as well. And so immediately after it had cured, then they actually put 2.5 inches of hot mix pavement for the wearing surface. And so that serviced road for about 20 years, and then they decided to take the 2.5 inches off, and they actually took some material in the 6-inch base to about 3/4 of an inch. Removed that too for one reason or the other. I don't know why, but it must have been showing some distresses or something. But so that went on then for about 10 years, and then they added 2 more inches. And then in 2016, there was a mill and overlay. So right now there's approximately 7 inches out there, and 5.25 inches of this lean concrete base. Now this base was actually composed of like a base aggregate and about 250 pounds per cubic yard of Portland cement and about 75 pounds of fly ash. And so this material, this was, it's about 50 to 60% of, say, what we use today in regular concrete pavement, but far more than really what our cement treated bases are today. If you We had one go down this year in the Grand Forks district there, and if you were to put it into a cubic yard comparison, it would be like about 120 pounds that went into that one. So it's significantly more than just a cement treated base. So this type of research they were doing back in '79 actually came around again in about 2010. There was a number of test sections built with this same idea. One of them was actually at Minroads. And I think there was about 3 years worth of research, and it actually turned out pretty good. And so it was actually part of a SHARP 2 initiative in 2013. So Eob and his partner here, Thomas Calhoun, drove up on August 13th, and it was a beautiful day and no wind or anything. And so we met at the district. Arlene and I drove out there with them. And they set it up. We were at the Larimore Rest area here, and it took them about 20 minutes to get everything set up. And so once that was done, then they were ready to go. Here's Arlene with Eob going to drive. And then Thomas is actually watching the computer information as they're going through, as they're collecting the data. And so they drove the 12 miles and collected the data, and they traveled about 40 miles an hour. And they did both lanes of the, and they were shadowed, or I should say, followed by, protected by a maintenance attenuator, such as the one you see here in the photo. So after they collected the data, they drove back into Grand Forks, and we had about an hour session in the conference room, kind of going over the preliminary data. And there was a number of representatives from the central office came up that day. And and then after that, we had like a show and tell and kind of demonstrating the van and what it had and everything. So, but it was really a good day. Everything turned out really good. So I'm going to go over some of the data they sent me. And then I'm not an expert at any of this. So they sent me a lot of these slides, Eob and Thomas, and pointed out some things. And so I guess I'll just start with this one. So there's you see my cursor here. This area here is the concrete base that they're detecting down there. Anything above that is the asphalt surface, or the thickness of the asphalt. And so here's another one kind of showing the strong reflection again of the concrete base. This particular one here, though, one of the things they're not that doesn't seem to be as consistent is the bottom of the concrete base, which is about 5.5 inches down from the top, or 5.25. And so they at times they see it, and sometimes they don't. They think maybe it has something to do with the aggregate gradations being kind of similar. And so, you know, this whole GPR, 3D GPR is in development. So, I mean, there are a lot of things they're still looking at. And part of this project and coming up here was unique to them too, because they didn't have any sections like this. And so this is research really going on, and to see how they can improve things. And so here's the two gradations. I actually looked it up in the SP. I found it in the archives for the concrete base, and then I went into 1976 specifications and found out that's what was used was class 5 under this 2 inches here, the 2 inches of aggregate base below the concrete. So they're not really dissimilar, I don't think. I mean, there's some similarity to the aggregate gradations here, if you were to go right down through the middle of the bands. So that might have something to do with it. Here's now one thing they were able to detect more so was the bottom of the aggregate and the subgrade, which of course would have a lot different gradation there. So they could actually detect that more so. And also, as you've seen in some of the other photos here, these are transverse cracks. And this big screen, or the big image here, is actually, as if you're looking at it from the side, like you were standing in the ditch and over here is the width of the roadway. And down here is if you were on a drone or something from the top. And so here's your transverse cracks. So you notice that one thing that we were all wondering about with this stuff that keeps coming up is the concrete cracked under there? Is it causing the cracks? And more than likely, that's what's happening, is that the cracks started out in the concrete base and moved up and propagated through and reflected through to the asphalt above. So we also did some coring on this section just to verify some of the results we got with the GPR data. And so we took around 14 cores. And you see Arlene here with Paul Gilmore from the Livermore section, who provided the traffic control for us during that. So here's one of the cores we took. We took them in a variety of places. We took one right over a crack area. And this actually had kind of a junction there with a longitudinal crack as well. But you can see how the concrete, I think, is, has worn away and raveled away, probably because of the water over the years. It also seemed to ravel away the concrete base as well. As you'll see, we'll have better pictures of that base as we keep going here. But Eob and Thomas thought that there was some anomalies going on there that's consistent with, say, stripping of aggregate or of asphalt. Here's one where we took in a rutted area, rut being about 2 inches deep at the deepest part. So we took a core there. We took a core in the middle of the lane. And you see them over here to the left. They're actually in fairly good condition. What's interesting, though, is I still kind of wonder if the base material, the concrete base, has been punched down a little bit from that rut. When I look over to the right here, in the width, part of the width of the pavement, it almost looks like the core that's in the rut has actually got lower. The base seems to be lower in that area. I don't know, maybe it's just the way it shows up there, but here's another one where we took in a crack area. Once again, this was a severely stripped asphalt section. There was actually, the concrete is there too, it's just that it came up in aggregate. It completely disintegrated it. And to the fact that we weren't even sure if there was concrete there, but afterwards we looked in the hole and got a light down in there, and we could actually see the walls of the base down there. But it, and then we tried to, kind of chip away at it. It was fairly easy to chip out. So I think it just, there's a possibility that the moisture over the years has just deteriorated it. Here's a really nice core, both that concrete and the asphalt. It was taken in the area that did not have a crack. You can see a pretty good indication here, in this case, of the bottom, where what they think is the bottom of the concrete base, where the arrows are here. Here's another one where, not all the time did they get real clear images. Sometimes it would, over to the right, it seemed to be a bit more blurry. So they're going to be looking into some of that to see why. Here's a core where Arlene and I took, it was on a vertical curve, kind of just coming down into a sag curve. And it was in the driving lane. It was about a foot thick. And actually, Eob was looking at the data beforehand, and they saw like an anomaly right in this area, as you see to the left. And so we didn't find any concrete base here. Something happened. I haven't been able to locate any plans to say otherwise, but there just wasn't any concrete base down there. And it actually shows that way, I think, that there wasn't anything there. So that was interesting to see that. Here is another one where it's like, the concrete, like in core 6 here, actually broke away and was actually, I think, was cracked. So it almost tells me that, maybe there's some cracking going on down there that It's not really reflecting through. And so there might be more cracking down there than we think. In fact, there's another set of cores I didn't include because it's kind of the same thing, but actually that also was cracked in the driving lane as well, but no crack on the top. So here's a kind of a neat thing too that so in the original plans in 1979, there was a note in here stating that the econocrete base was to seize prior to getting to the junction 18 here, which runs north and south, the Larimore turn here. And then once you're over past the highway to start up again. And so I think they did this because they just had done a pavement through here and they didn't want to get involved with the intersection. So that's what they did. There was a break, and as you can see to the right, it actually shows that it breaks there. It's about 50 feet there, right in that area. So that was neat. This is a bridge structure. We'll just kind of pay attention to the bottom one here, the eastbound section. You can see in the passing lane, the driving lane, the GPR data, that's quite the difference there. One thing we noticed a little bit later was it seems like just right of the in both cases, just right of the bridge, the concrete base, the top of the concrete base seems to lower there. It's like it's thicker asphalt, and I suppose there's the possibility that because of all the patching that we've done, you can see some patching here over the years, that maybe the asphalt is a little thicker. Also, what cores we had that didn't ravel away or anything like that, we measured, and they gave us a spreadsheet. So these aren't exact locations right where the core is, but I believe they're going to probably is going to get me that information. But there was a spreadsheet that had every 40 feet or so or whatever, they took a picture or a measurement, and so I included these, and then the core lengths as well. So none of them are really far off. I think probably an average of about a 1/4 inch difference. If you averaged all of them over together here to the right, between the GPR data and the core data, it's even less than a 1/4 of an inch. So that was pretty encouraging to see that. So some things that a number of us after we had that open house, we got together on a Teams meeting and we kind of brainstormed some things that we thought would be interesting to use for applications. One is project scoping surely stands out as a way to get better information before we start figuring out what we're going to do. I think that's really important that we have this kind of data for project scoping. Thickness designs, I could see that if you have more exact thicknesses and what the variability is more, that it might affect having more accurate thickness designs as well. Subsurface conditions, it could complement this data. Technology could complement, say, linear soil survey information. Effective strength of existing pavements, it could work very well with the FWD. I think every time that weight of the FWD is dropped, it's nice to know exactly what you have down there. Pavement management, I think it would work, complement the pathways van. And identifying existing, underground utilities, especially in cities and urban areas as well. Moisture detection of unwanted moisture in our roadways. Like all the other technologies we have, the 100% coverage is definitely an advantage to have all that data, just as the DPS and intelligent compaction and thermal profile. Automated milling, where you have a lot of heavy milling that has to go on, or removals. It would be good to, I think, since all of this data has a GPS coordinate to it, that it could be used, I would think, during the milling process. Spring load restrictions, again, we rely pretty heavy on the FWD. It may have some bearing and complementing that as well. Bid supplementary information. When we start bidding projects, it would be nice to know some of this information maybe beforehand. Maybe we'd get better, more economical bids. in the future, not that this is really part of it yet, but it could be, and that's the concrete bridge deck evaluations, and then asset management and as-built documents. I think it'd be nice to have something like that. The VEDA program. I borrowed this slide from Rebecca Embacher from MnDOT, but GPR is actually in here. There's been a lot of work actually done. It's just that the funding hasn't really came through yet to finish it up, but it would be nice to know that you can overlay all this stuff and map it out as well. So I think with all our applications and benefits, I think safety it has to rank right up there at the top. I think if Arlene and I were out to go out and do a coring across the whole section here, it would take us up to 3 days. And we're exposed to traffic, ongoing traffic, and we all know what that's like out there. They don't slow down, and so we're out there a long time. And actually, this data that they collected for this road only took about 40 minutes, 35 to 40 minutes, I'd say, and they were done and drove along at a fairly safe speed, 40 mile an hour, and so that has a lot to do with it. And so that's all I have. So thank you very much.